What is VRRP? VRRP, Virtual Router Redundancy Protocol, is a protocol that allows multiple routers to work together to provide network redundancy. In a VRRP setup, routers are grouped into a virtual router where one router becomes the master, or active router, and the others are backup, or standby, routers. The master router handles all the network traffic under normal conditions, but if it fails, one of the backups takes over, ensuring continued network availability. How VRRP works. Master router, the active router responsible for forwarding packets to and from the network. Backup routers, standby routers that monitor the master. If the master becomes unreachable, the backup with the highest priority takes over as the new master. High availability ensures network availability by automatically switching to a backup router if the master fails. Seamless failover allows for minimal packet loss during failover, providing a smooth transition that users typically won't notice. Load balancing, with multiple VRRP groups. Different groups can be set up for various segments of the network, balancing the load across multiple routers. Simple configuration. VRRP is relatively straightforward to set up, especially on routers that support it out of the box. Interoperability. As an open standard, VRRP can work across routers from different vendors, unlike proprietary protocols like Cisco's HSRP. In this lab setup, we'll configure two Mikrotik routers for redundancy. One router will act as the primary, master, router, directing traffic through upstream 1. If the primary router fails, LAN devices will automatically switch to a backup router, which connects to upstream 2. We'll achieve this failover using VRRP on our Mikrotik routers. Let's begin by configuring Office Router 1 to act as the master for VRRP. First, we'll change the router's identity, and then verify if it has internet access. I'll label all my interfaces to make it easier to set up VRRP and the DHCP server later. I'll configure the VRRP master on Ether port 2 with a VRID of 20 and set its priority to 200. This setup designates router 1 as the preferred master, ensuring it takes control when available. The higher priority value, 200, makes it the default master in this VRRP group, allowing for seamless failover and optimized network resilience. I'll set up Ether 2 as the LAN interface with the IP address 192.168.1.1/24 and configure the VRRP interface with 192.168.1.10. When we configure the DHCP server, we'll use the VRRP IP 192.168.1.10 as the default gateway for the 192.168.1.0/24 network range. This approach allows DHCP clients to use the VRRP interface as their gateway to access the internet, providing automatic failover and network stability in case the primary router goes down. We can now see that the VRRP interface is active and operating as the master. I'll set up the DHCP server on the VRRP interface. Since VRRP operates with a /32 prefix, we'll need to specify the /24 network prefix, 192.168.1.0/24, to ensure that DHCP clients receive IP addresses within the correct range. Keep in mind that with the changes we've made, the DHCP server will ask if we need a relay server. Since VRRP is handling the gateway role, we do not need a DHCP relay. The VRRP master will act as the default gateway for the clients, and the DHCP server will assign IP addresses directly to the devices on the network, eliminating the need for a relay. Let's configure source NAT, masquerading, for our local LAN, allowing traffic to be routed out to the internet. Let's check if we have internet connectivity and verify if the default gateway for my local LAN is set to the VRRP IP 192.168.1.10. Everything is working great. We have internet connectivity, and the default gateway is set to the VRRP IP. Let's configure the office backup router, which will be connected to the second upstream provider. I'm configuring the backup VRRP router on Ether port 2 with a VRID of 20 and a priority of 100. This setup ensures that this router will act as the backup in the VRRP group. The lower priority value, 100, means this router will only take over the master role if the primary master becomes unavailable, providing seamless failover for network reliability. The VRID of 20 allows this router to participate in the specific VRRP group. We need to replicate the LAN, DHCP, firewall configurations from the Office Master Mikrotik onto the backup. This way, if the Office Master fails, the backup will take over, ensuring that DHCP clients can still access the Internet without disruption. We've updated the backup router's IP address to 192.168.1.2/24. This change allows the point-to-point connection between the master and backup routers, ensuring they can communicate within the same VRRP group. By having both routers in the same subnet, the VRRP group will function properly, enabling seamless failover between the master and backup routers if needed, while maintaining network continuity for the clients. The VRRP status is showing red, which indicates that the backup router is currently active. Now, let's reboot the main master Mikrotik and verify if the backup router takes over as the master. As we can see, the backup router is now active and functioning as the master. Let's wait for the master router to come back online and observe if the backup router transitions to a disabled state. As we can see, the master router is back online, and the backup router VRRP has gone offline. Thank you, everyone, and I'll see you in the next video.